Joe, it's a pleasure to meet you.
Good meeting you.
I heard a lot about you, actually, from Ty and Santa Fe and everything you have worked on and are currently working on. So
It keeps me busy in an area that I'm not really active in, precious metals per se. I'm from another industry, but applying our technologies to jewelry and precious metal applications.
what other options besides SLM are currently available for powder metallurgy in the jewelry field?
Well, there's traditional powder metallurgy, which is what I started to promote, 30 years ago, which would be press and sinter and metal injection molding, which are very typical in my industry right now for making, a myriad of parts. I mean, there's a $6 billion industry in North America making primarily iron-based parts from metal injection molding and press and sintering. So those technologies are readily available. There was some other activity by some other companies, but it never went forward. And the main thing is powder supply. And the same thing with MIM. MIM makes all the same generic parts that jewelry does, these small findings, and parts that are made by the thousands that are really background parts, finding, The jewelry companies didn't want to embrace it because of the lack of powder. And it's not that it was scary to buy an atomizer, but no one wanted to be the first one on the block to do it.
Got it.
So you've got those two base technologies, and then you've got all the new additive manufacturing. You mentioned SLM. And we gave that a certain amount of attention because it is a powder metal method. But it doesn't involve sintering like conventional powder metallurgy. So now there are several different additive manufacturings which we call sinter-based. So for instance, you have the binder jet. You've got fused deposition modeling with a filled filament, and you've got vat photopolymerisation. And there's also material jetting, where it actually goes through the inkjet head, but that's rare. But as far as binder jet, that's essentially like MIM. You're printing a part of metal powder and a binder. And so you can take that, and the rest of the industry, my industry, powder metal industry, says, I can do that because I can leverage all my sintering technology. And the same thing with fused deposition modeling. And then finally, even the vat photopolymerisation. It's all making a metal polymer, which then sees conventional powder metallurgy technology to process it, debind and sinter.
What do you see as some of the breakthroughs over the near term in regards to this tech with the precious metals?
So it's always been the issue of, okay, it works, where am I going to get the powder? And
exactly.
The good news is overall that there are several new entries in the companies that build atomizers, and we've been doing it for 30 years, but we have competition, which is good because it helps everyone move along. And we all do slightly different things, but it's also a barrier because it's easy enough to atomize silver and gold alloys. That's very easy to do with either a gas or a water atomization system, and they're not even that very expensive. But platinum requires a whole different system. And mainly it's because the melt temperatures are so high. So the main barrier is getting a crucible that can handle platinum. And you might say, well, they cast platinum all the time. But when you cast platinum, you heat it up to the melting point and you fling it out into a mold. With atomization, you heat it up and you're holding it for 10 or 15 minutes with a 200-degree superheat. Where's that crucible coming from?
Right.
So there are some technologies available, very limited, that can atomize material at that level. But coming on, additionally, there are some non-crucible based atomization systems that show potential for working with platinum. For instance, they are the ones that use a wire. So if you have a source of platinum wire, now you can directly atomize. And some use essentially equivalent to a TIG torch. They melt it on a substrate, and the substrate vibrates ultrasonically and flings these particles off into the distance. So the technologies are not necessarily aimed at platinum. Our system is not aimed at platinum, but it will do wire. It doesn't matter. I guess it's wire agnostic. It doesn't care what wire you put into it. It makes powder.
When do you expect to have the beta system?
Well, today's Tuesday. We expect to have the beta system out the fourth quarter of this year.
Oh, wow. That's very exciting.
But it will actually be at our facility operating for somebody else. So we'll kill ourselves first and then
there you go.
Elsewhere.
Well, that's exciting. Well, I appreciate the time today.
Oh, my pleasure.
It's been a pleasure to meet you.
Good meeting you too.
Thank you.